Okay, so let's look at how we can use determinants to help us solve a system of equations. If you've read the previous parts of the notes, we have this new rule, Kramer's rule, that utilizes determinants to help us find this. So the first thing we will do for ourselves when we use Kramer's rule is you want to make sure you can set up all your determinants that you need. So make sure all the equations are in standard form. And remember, standard form is the x comes first, the y comes second, and the constant is on the other side of the equation. So we can kind of see that that second equation is right in standard form. However, the first equation, we would need to rewrite it. It looks like we'd have to subtract 3y from both sides. If we do that, we will get x minus 3y equals -4. And then just for purposes of visual, I will write the second equation below it. So just make sure your x terms line up, your y terms line up, and then your constants at the far right. So first thing, let's make this determinant. It's kind of like an augmented matrix in a sense, but let's just call it a determinant with using the bar notation. So D will equal, or this is called the determinant of coefficients. We're just looking at the coefficients of the x. So that's going to be 1, 2, -3, and -1. And so we have our x column and our y column. Now, if it helps, you can calculate the determinant right away. Sometimes what I like to do is set up everyone first. So that's what I will do. My D sub x. This is going to be my determinant of coefficients, except the x column will be replaced by the constants. So we will have a -4, 7, and then the y column still remains the same, -3, -1. So that's where we see our d sub x from. The x column gets replaced with the constants. Similarly, you want to set up d sub y while we're here. Might as well. We will take our determinant of coefficients. And remember, it's the y column that is now going to get replaced with the constants. So in our case, the constants were -4 and +7. And this means we just take the same x variables, or the coefficients at least. So we also have 1 and a 2. So now all we have to do is calculate each determinant. So we'll do that. And I could do this with a TI, but I'd rather do it by hand. It's a little faster in my sense, at least with 2x2s. So remember, if you're going to calculate the determinant, we are looking at 1 times -1, subtracting off 2 times -3. If you prefer, we can move, I'll move sideways, helps me out a little bit. -1 times +1 is -1. I'll color code that for you so that you can see. I then have plus a 6. And what we get, -1 plus 6, just gives us a +5. So that is our value for D. Now, next stage, what we're going to do, same thing, determinants. -4 times -1. Subtract off 7 times -3. So let's simplify that just a little bit. We have +4 plus 21, which will leave us with a 25. So that's our d sub x. And I'm only circling them. The work will help me out, but they are specifically asking us to give the values of those determinants. not just the solution. So next stage, d sub y. We're almost there. We have 1 times 7. And we're going to subtract off 2 times -4. So this will leave us with 7. And then we're looking at plus 8. And if we simplify this just a little bit, we are getting 15. So we now have, maybe I'll be a little bit more precise. I know we can see this in our work. D is equal to 5. D sub x equals 25. And D sub y equals 15. But sometimes they'd like you to specifically state what they are. So that's part of it. We're almost there. This last part is just using Kramer's rule. So I'm going to move off to the side a little bit. And just remember Kramer's rule. Super cool. If you already have the d sub x and d sub y, it just gives you the value of who x is and who y is based on the value of the determinants. So x is equal to d sub x divided by d. And if we're going to write out what we have, our d sub x was 25 and our d was 5. And if it's possible to simplify, we do so. And this one's nice. 25 divided by 5 is 5. And y, you guessed it, d sub y divided by d. So d sub y is, isn't it 15? And again, we're dividing by d, determinant of coefficients, which is 5. So we get y equals 3. So then if we're looking at naming what the solution is, it is an ordered pair. X comes first, y comes second, and we have all components of what they're asking for. So don't forget we have the solution. And they also wanted the values of d, d sub x, and d sub y, so we make sure that we state those as well. So that's how you use Kramer's rule to solve a system of equations. You can extend this to 3 equations and 3 variables, and you'll probably be wondering how. Well, stay tuned for the next example.